In this video, we're going to discuss how we find a least common multiple of two monomials or two numbers. First off, what is an LCM or least common multiple? It is the smallest monomial or number, if we're dealing with numbers, that can be evenly divided by two or more given monomials or numbers. So that means that it is the smallest monomial that is a multiple of whatever monomials we're given. So let's look at a first example and kind of see the idea behind this process. We're going to find the least common multiple of 12 and 18. Now on its basis, we're looking for the smallest number that is a multiple of both of these numbers, 12 and 18. And so one way we could approach this is we could just start making a list and list out the multiples of 12. 12 times 1 is 12. 12 times 2 is 24, 12 times 3 is 36, 12 times 4 is 48, 60, etc., etc. And we could do the same thing for the multiples of 18. 18 times 1 is 18, 18 times 2 is 36, 18 times 3 is 54, etc., etc. And the least common multiple is going to be the smallest number that we see that appears on both of these lists. And if you look at these two lists, we can see the smallest number that appears on both of them is 36. And so 36 is going to be our least common multiple for these two. Now, especially as the multiples get bigger and bigger, this gets to be a bit of a tedious process, listing out all the multiples. So we're going to look at some other ideas as far as how we can find LCMs a little bit more simply than just, chugging out a list of multiples of the numbers. So here's a process that we can use. To find the least common multiple, what we can do is we can take the prime factorization of both of the monomials, and then we're going to identify all the factors that appear in the two factorizations. Notice it says here, if a factor appears in both, we're only going to count it once. So suppose I've got a 2 in the one factorization and a 2 in the other, I'm only going to count that one time. But then if we have another 2 that appears in one of the factorizations but not the other, I'm going to count that as well. And we'll show you what's going on here. So we'll start with the factorization of 30. 30 is, let's see if I break this down into primes, that's 2 times 15. 15 is 3 times 5. So 30 is 2 times 3 times 5. And then I'm going to do the same thing with 75. 75 is 5 times 15. 15 is 3 times 5. So the factorization of 75 is 3 times 5 times 5. Okay, so we want all the factors that appear in both of these numbers that appear in either of these factorizations. And if they appear in both, we're only going to count them once. So see, we've got a 3 that appears in both. We've got a 5 that appears in both. And then we also have a 2. And we have another 5 that only appears in the factorization of 75. So we're going to take all of those numbers and multiply them together. So we've got 2 times 3 times 5 times 5. Notice for the pairs, we only put one of that factor in our factorization. See how the numbers line up here as we break down this factorization. And now we're going to multiply all these numbers together, and that's going to give us our LCM. Our LCM here is 2 times 3 times 5 times 5. If you want, you can go ahead and calculate that out. We're going to take 2 times 3 times 5 times 5. And so the least common multiple of those two numbers is going to be 150. All right. Let's do the same thing with our second pair here, 8x to the 5th y squared. And that's equal to 2 times 2 times 2 times x times x times x times x times x times y times y. And 4x to the third y to the third is 2 times 2 times x times x times x times y times y times y. And we'll look at the pairs here. We've got a pair of 2's and a pair of 2's, and then we've got an extra 2. We've got a pair of x's, a pair of x's, a pair of x's, and then a couple of extra x's, and then we've got a pair of y's, a pair of y's, and an extra y. And so we're going to multiply all these things together to get our LCM. So we've got 2 and a 2 and another 2. That takes care of all of these. And then we've got an x and an x and an x, and then the 2 extra x's from the factorization of 8x to the 5th y squared. And then we've got a y and a y that appears in both, and then an extra y from the factorization of 4x to the 3rd y to the 3rd. We'll multiply all these out. 2 times 2 times 2 gives us 8. X times x times x times x. That's x to the 5th. And y times y times y gives us y to the 3rd. And so that is going to be our least common multiple. Now, if you look at what's going on with the variables, hopefully you can pick up on an idea that's going to be a little bit of a shortcut for you for determining what power of the variables should appear in the LCM. All right, let's do a couple more here. I'm going to find the LCM of these pairs, 12x to the 6th y and 30x squared y to the 5th. So I'll start with my factorization of 12x to the 6th y. 12 breaks down as 2 times 6, and 6 is 2 times 3. So that's going to be 2 times 2 times 3. And then we've got a bunch of x's and a single y. And then 30x to the 2nd y to the 5th. And 30 breaks down as, let's see, 5 times 6, and 6 is 2 times 3. So 2 times 3 times 5 times x times x times y times y times y times y times y. Alright, and so now we're looking for our pairs. We've got a pair of 2's, we've got a pair of 3's, we've got an extra 2, we've got an extra 5. So that turns into 2 times 2 times 3 times 5. And then my x's. Got a pair of x's, a pair of x's, and then 4 extra x's. So we're going to have 6 of them in total. And then we've got our y's, we've got a pair of y's, and then 4 extra y's. You know, y times y times y times y times y. And we multiply all this out. 2 times 2 times 3 times 5 gives us 60. And then there are 6 x's and 5 y's. And our LCM is going to be 60, x to the 6th, y to the 5th. Have you picked up on it yet, what you're going to do with the powers of your variables? Stop and think and see if you have come up with it yet. If not, we'll give it one more shot here. We've got 10 x to the 3rd, y to the 4th, which is going to be 2 times 5 times x times x times x times y times y times y times y. We've got 25x to the 2nd, y to the 2nd, which is going to be 5 times 5 times x times x times y times y. And now we'll look for our pairs. We've got a pair of 5's, we've got an extra 2 and an extra 5. Pair of x's, pair of extra x. Pair of y's, extra y, extra y. And so we've got 2 times 5 times 5 times x times x times x times y times y times y times y. And that gives us 50 x to the 3rd, y to the 4th as our LCM. Alright, hopefully you picked up on it by now. Let's go over to our last slide where we're going to actually talk about the basic ideas of how we can avoid doing all this longhand work. Some pointers for finding LCM that we should know about. First off, we can use a calculator command to help us find the LCM of two numbers. Just numbers, not the variable portions, but the numbers. And when we have variables in our expressions, the largest power of the variable that appears is the one that should appear is the one that should appear in our least common multiple. So here we go. We're going to find the LCM of the following pairs. We're going to take our numbers, and we're going to go to our calculator. In the math menu, over where number, remember where we found the calculator command for the GCF? Well, right above it, number 8 is a calculator command for the LCM. We're going to go ahead and use that. LCM of 35 and 49. That's 245. And then I want the largest power of the variable that appears in the 2. I've got x to the 8th and x to the 12th. X to the 12th is the largest. And then for my y's, I've got y to the 11th and y to the 7th. The largest power of those is y to the 11th. So that's the one that's going to give us our LCM. We'll do the same thing in part B here. Go ahead and use our calculator to find the LCM of the two numbers. Under math, number.
That all cars must be removed from the bus lanes by 11 o'clock this morning. Thank you.
And the LCM of 24 and 40 is 120. And we've got the largest power of x. We've got x to the 6th and x to the 19th. The largest is x to the 19th. And we've got y to the 12th and y to the 4th. The largest power of those is y to the 12th. And so there's our LCM. And that concludes our video on how to find LCM. Sorry, I don't know if the mic picked up some of those interruptions that were happening throughout. I apologize for that if you found that distracting. I'm not even sure if you heard those through my mic. All right. Thank you much.